All right, so your homework here was page 6, and we did one at least together, but let's go over the rest of them. What'd you get for people in the United States? How do we abbreviate or scientific notation that one? 2.5 times 10 to the 8th. That is also what I got. Somebody else give me people in the world. 4.5 times 10 to the 9th. The lakes one, this one confused some people because this would work, the 1.0 times 10 to the 4th, or for this class, 1 times 10 to the 4th. These both mean the same thing. Technically, this is the right one, but for our class, I'll take either one. Next year in chemistry, they'll teach you, this is the absolute proper way. It's called significant figures. They teach that to you in chemistry, you use it in physics, and if you go to college, it's important. For science, it's important. For this class, basic. As long as you get this, I'm good. This one, miles in a light year. Who counted those zeros? Or those decimal spots? Wait. Lily. Person after Lily is... Nope, I know this. Maddie, what do you got? 9.5. That is what I got. That's a 9.5. I think we ended up talking about this one together, didn't we? Okay, so again, for this one, in case you weren't here on Friday, the same deal. You always want to move the decimal point between the first 2 digits and the number. It was here, so when you move it over, you keep the 6.242, and you would have to move the decimal 18 spots to get from here over to here. That's an 18, sorry. Oh, that didn't make it better. That's an 18. Dollars the president makes in the year, which, by the way, I'm not sure if this is true. If it is true, I think he's not making enough money because that's a really busy job. And anyway, moving on. What do you got? That's what I got. Were you guys comfortable going the other way? We give it to you in scientific notation. You have to undo it. So this one, 6.38. We got to move it 6 spots. 1, 2, 3, 4, 5, 6. This is where the decimal would go. So you fill in the zeros. That's 1, 2, 3, comma, 1, 2, 3, comma. So, right? 1, 2, 3, 4, 5, 6. So that's 6380 with 4 zeros added. 1, 2, 3, comma. 1, 2, 3, comma. 6,380,000. The blades of grass one here, I'll just put that up there because that's a lot of zeros. We will never have one that's that long. They'll all be much simpler like these ones. And then finally, the clay, that's 22,110. Guys got scientific notation?
Yep.
If you need more work on it, let me know, but this is the last time we do scientific notation in class. Okay? I did realize that on Friday with everything going on, I ended up forgetting we needed to finish the notes on page 2. I knew we were finishing way too early. I couldn't figure out what went there. So we're changing it up, going back to 2. So we were really good. You guys were really good at making observations. You got really good at making inferences, so things you guess about. You guys got pretty good at making predictions, so just a guess about the future. And this is where we left off. Are all predictions easy to make? Not really. What are some predictions that are easy to make? Like, you know that your prediction is going to be correct about something. Is there anything you can predict that you're sure you're right about?
That's lunch next period.
How do you know you have lunch next period?
Schedule.
Because it's the schedule. Every day your schedule is the same. First period, second period, third period, fourth period, fifth period, sixth period, seventh period, eighth period, ninth period, start all over again. So you know you have lunch next period. Anything else that's that easy to predict? Tomorrow's Tuesday, because the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, goes on. What, you said something different, right? Your birthday is on the same day or the same date every single year. Could you figure out what day it's going to be on as easily? No, but could you? You could. So what, like Monday, Tuesday, Wednesday, those things, is not as easy, but if you sat down with the calendar, you'd be able to figure it out. Anything else? Can you think of anything in science that's that easy to predict? There's a few things, not many though. The days, so the 24 hours, the earth turns every day. That's normal. One other, so here's the word cyclic. This is the, right under predictions, it's predictions, and then we're on page 2. And we're underneath predictions, it says letter A, cyclic. What do you see in the word cyclic? Cycle. Anything that happens in a cycle is easy to predict. So I'd like you to add this to your notes, page 2, underneath prediction. For us this year, the most cyclic thing that we're going to talk about in science are the phases of the moon. Do you guys know the moon has phases? We're going to make sure you know that this year. You're going to learn how to predict them and everything, but I'll let you know they always go in a pattern. We always start with a new moon, that's when there is no moon at all, to what we had last night, which was called a waxing crescent. That's when it's just a little smiley face. And then it grows, so you get the first quarter, then what's called the waxing gibbous onto the full moon, and then it starts to shrink. So we go from the from a full moon, we go to a waning gibbous, down to the third quarter, down to a waning crescent, back to a new moon. It's so predictable that if you wanted to chart it out and figure out what the moon phase will be the day you turn 21, you could figure it out. I guess technically the night you turn 21. But if you could sit down and chart it out because it's that predictable. What would be some things that were not easy to predict in science?
Weather.
Yeah, the weather. Now, you know it's going to be colder in December than it is in August, but do you know if we're going to have a blizzard on December 14th? No. Hurricanes. We do know there's a hurricane season. It's actually like around now. It's when there are more hurricanes now than there are in like February. But again, do we know if a hurricane's going to hit January 15th? No, we don't know that. But again, we know that chances are higher than in a different month. Earthquakes are another one, in fact. So here's the non-cyclic definition. It's an event that occurs randomly. They can't be predicted. And the best example I have for us is earthquakes. Now, yes, earthquakes happen more frequently in California than in Buffalo. But again, we can't predict exactly when there's going to be one. We just know there are higher chances, but we can't nail it down to what day. We're not overcomplicating these things. All right, and the last word is classification. I think you guys became masters of classification last year. What were some things you classified last year? Cells were one of them, plant and animal cells. You guys remember your beloved birds?
Oh, yeah.
Oh, yeah. Those finches, how'd you classify finches? So you looked at their beaks. You didn't really look at, I don't actually know what you didn't look at because living environment has those like living things and I don't like them. But you looked at something you could easily observe, the size or the shape of their beak, and you put them in groups based on that. What's one way I could put you guys in groups?
Hair color.
Hair color, eye color. I could put
Height.
I could put hoodies and not hoodies. Shoe size. Could I, by just observing you, put you in groups of who's cold and who's not cold?
Probably.
I would have to assume things. I would have to, like, I can't just look at Riker and say, oh, he's wearing a hoodie and pants. He must have been cold. He just might like hoodies and pants as opposed to shorts and a t-shirt. I know I'm more comfortable in hoodies and pants. So you can't guess or assume. So I can't just by looking at you say, everybody who likes dogs over there, everybody who likes cats over here. Okay, I cannot look at you and see that. So feelings or anything you have to guess, you cannot classify. This year, we're classifying rocks. So we'll be putting rocks into groups based on how they're made. Igneous get made by melting rocks. Sedimentary get made when sediments get glued together. And metamorphic is from heat and pressure. My coffee's empty. That was a sad day. All right. So like I said earlier, you do have homework. We're not doing it now. We're not done. Don't get that excited. We're only about halfway through. So you do have homework. We do have to go back in the packet a little bit. These are the Regents questions that go with observation, inference, and prediction. You have 7 questions for homework, guys. How long do you think 7 questions will take you?
7 minutes.
If that, to be honest. These are fairly simple questions. I'm thinking your homework will take you between 5 and 7 minutes. Is that a lot to you guys?
No.
Like, do you feel like that's like a fair amount of homework? Nobody thinks I'm overloading you?
No.
Okay, so what I'm asking you is to actually put in the effort. Try 4 or 5 minutes. Please don't just circle answers on this. I know you'll get 100 tomorrow then. On the way I grade it, it'll be done. Great, that's better than nothing. But I need to make sure you guys understand how to read Regents questions about observation, inference, prediction. Because if you didn't notice over there, underneath where your homework is listed, we're going to have a quiz on observation, inference, prediction on Wednesday. So it'll be 10, 15 minutes. We'll continue on with the day after the quiz, or actually I might even do the quiz later, like at the end of the period. That way I can just see if you, okay, so did we do a good job or is anything I need to redo with it? So just try so you know before Wednesday if you need help. All good? That's your homework. We're going to switch then to page 7. What's going on in Mr. Miga's lab? Did you guys start a lab today or on Friday? You're gonna start it Tuesday and Wednesday? Okay. How about Mr. Winters? Did he start this sunspot lab yet?
He like introduced.
You handed him out? Okay, perfect. So we're all about the same spot. I kind of wish I would have waited one more, Jay, so that we would have had this lesson first, but it is what it is. You guys who are in lab, nobody I don't think suffered very much. So the next lab that we're doing is called the Sunspot Lab. It's a lab about sunspots, but it's really a graphing lab. So graphing is huge in earth science in general. So we do a lot of taking data and putting it on graphs because graphs make data easier to read than just glancing at a chart. So you need to be comfortable graphing. You need to know what goes on the X, what goes on the Y, because you can't just pick. There is a reason something goes on the X and something goes on the Y. You have to be able to number it correctly. Can't just always count by ones. You have to make sure you can make a title. So we're just going to practice that real quick here. On this page, it says, let's graph. So in here, it will talk about the rules for graphing. It says graphing is an important procedure used by scientists to display data that is collected during a controlled experiment. Line graphs must be constructed correctly to accurately portray the data collected. Many times, the wrong construction, not constriction, construction of a graph detracts from the acceptance of an individual's hypothesis. A graph contains 5 parts. By the way, I didn't say this in lab, and I'm not sure if Mr. Meager or Mr. Winters will. When we're grading your graph, it's worth 5 points, and here's where those 5 points come from. So it needs a title. The independent variable put in the right spot, the dependent variable put in the right spot. The scales for each have to be correct. You can't just willy-nilly do them. You have to make sure they make sense and they follow all the rules. And then if required, a legend. So sometimes you might need to do one in pink and one in green, or one with stars and one with dots, just so you know which one's which, and then obviously label them. The title, by reading the title, a reader should get an idea about the graph. It should be a concise statement placed above the graph. Now, here's the next part. You're going to be given completely blank graph paper, and you have to decide what goes on the X and what goes on the Y. It is always the independent variable, which is the one that is controlled by the experimenter. It usually includes time, dates, hours, minutes, depth in feet or meters, or temperature in Celsius, and it is always placed on the X-axis. The independent always goes on the X-axis. So the one that you can control goes on the X-axis. One thing I get every year is it says time goes on the X-axis. Guys, how do you control time? Because last time I checked, that clock ticks the same speed, no matter how fast or slow I want it to go. So how can you control time? Like, how is that the one that's you're controlling? You think you can't? You can.
Like, you can I don't know how to put it into words, but every 5 minutes you can do something.
That's it. You control when you take the measurement. So you can decide, are you going to measure every 5 minutes? Are you going to measure every 1 minute? Are you going to measure once a year? Or the one in your lab, they take measurements of the number of sunspots every 2 years. So that's how you control time. You control when you measure. That's the only way. No, you can't speed up or slow down the clock as much as we wish we could, but you can control when we take the measurement. So time goes on the X-axis. Depth, as in this one. So this person decided what measurements they're going to take the number of bubbles at. So they decided, am I going down every foot, every 5 feet, or every 10 feet? All right, moving on, the dependent variable is the one that's directly affected by the independent variable. It is the result of what happens because of the independent variable. Example, how many oxygen bubbles are dependent on the depth of the water? This variable is always placed on the Y-axis. For this lab, the number of oxygen bubbles produced by a plant, would you ever be able to tell a plant, hey, could you make 5 bubbles today and 10 bubbles tomorrow? Like, you can't control a plant. Same with, can we control how many sunspots the sun makes? No. So the one that we can't control, that's always the dependent variable, and that will always go on the Y-axis. Moving on, the scales for each variable. In constructing a graph, one needs to know where to plot the points representing the data. And in order to do this, the scale must be employed to include all the data points. It must also take up a conservative amount of space. It is not suggested to have a run-on scale, making the graph too hard to manage. The scale should start with 0 and climb based on intervals such as multiples of 2, 5, 10, 20, 25, 50, or 100. The scale of numbers will be dictated by your data values. So when you're doing a scale, you know you can't always count by ones. A lot of you already know you can count by 2s, you can count by 5s. I always say count by something that you're used to counting by. Do you guys walk around counting things up by 3s? Then don't write your scale going by 3s. Is it technically wrong? No, but don't make your lives harder than they need to. If you are good at counting by 2s, that's a good choice. 5s, you guys should be good at 5. Nobody counts by 7s, right? Some people count by 12, especially if you have chickens and you put your eggs in containers of 12. So bakers who are putting donuts, you might count by 12s, but for us, we're not counting by 12s. Are 20s easy to count by? Yeah, because it's the same as 2s. Here I said 25 is also a good choice. Again, that's kind of like quarters. 25, 50, 75, 100. 25, 50, 75, 100. So that would be a good choice. But nobody's counting by 30s typically, because that's just like counting by threes. Just count by something you're good at. And make sure it takes up at least half the graph. That's what it means by run-on or conservative amount of space. Don't, if you have a whole sheet of graph paper, try to use as much as the graph paper as possible. Don't make a graph that's only gonna be down in this bottom corner. And finally, legend should be a descriptive narrative concerning the graph's data. It should be short and concise and placed under the graph. So all I want to do for the rest of this period is get your graph paper set up. So do you guys want to do that on your own, in groups, or as a class? Okay, so I just heard own/groups. How about I will give you, you are out of here at 12. So all I want you to do is set up, meaning put your labels on the right side. Hint, which one's going on the x-axis?
Depth.
The depth goes on the x. We're not even doing the questions yet. Sorry, I know we should have done that. Depth goes on the x, bubbles goes on the y. All I'm asking you guys to do is label, put the numbers on now. You don't have to plot. We're gonna do that tomorrow. I just want your x and y axis labeled with your numbers. You can either work on your own or together, and you're just gonna label them up and then be done. When you're done, if you wanna do your homework, that sounds like a good choice. Call me over if you need me, but otherwise I'm done talking to you. You have 8 minutes left.